Shall we start? Good morning, everyone, to this late breaking news. I am pleased to introduce this morning Mr. Dongnang Li on behalf of Mr. Wang Zhongyi, Deputy Chief Designer of the China's Manned Space Engineering Program, who will be talking about the latest developments of the Chinese manned space program.
On September 21st, 1992, Chinese government decided to implement the manned spaceflight program and approved a three-step development strategy. According to the step-by-step strategy, in step 1, China would implement the manned spaceflight and carry out experiments for space application. In step 2, China will master the generous and docking technology, launch a space laboratory, and carry out scientific experiments on a certain scale with short-term human participation. In step 3, China will build a space station and carry out science experiments on a larger scale with long-term human participation. The China manned space flight program is a national key project. It's also the largest space program of China. The program is composed of 8 systems, which are the astronaut, the space application, the spaceship, the launch vehicle, the launch site, the TT&C, the landing site, and the space lab system. The program started in 1992, and in November 1999, the first unmanned space flight test was conducted. In the following 3 years, China conducted another 3 unmanned flight tests successfully. Through these tests, the whole system and the whole program were thoroughly checked. In 2003, China successfully accomplished the first manned space flight. Taikonaut Yang Li Wei circled 15 times around the Earth in Shenzhou 5 spaceship and launched safely on the main landing site and Inner Mongolia. In 2005, China successfully conducted her second manned space flight, the Shenzhou 6 mission. It was China's first time for multi-man and multi-day space flight. Taikonauts Fei Junlong and Li Haisen entered the orbit modular, operated and conducted scientific experiments. After 76 circus flights around the Earth, they landed safely and healthily. Second, I will talk about the Shenzhou 7 EVA mission. From September 25th to 28th, 2008, China successfully conducted Shenzhou 7 manned space flight. It was also the first flight of the second step for China's manned space engineering. It made China become the third nation with key technologies of EVA. The main tasks of Shenzhou 7 mission was to conduct the first EVA, to master and make breakthrough on EVA technologies, to carry out space science and technology tests, such as accompanying satellite and data relay. Compared with Shenzhou 5 and Shenzhou 6, the Shenzhou 7 mission have made several technology breakthroughs, such as the VTM EVA spacesuits, the airlock, the EVA train, and the others. Since 1995, China had begun to research and develop key technologies and components for EVA, such as the water sublimators, Fuzhou movable joints, and liquid cooling car garment. In 2004, the development of EVA spacesuits was fully studied, and the design, prototype, and flight type were gradually completed. We produced multi-sets of spacesuits for ground training and use in orbit. The VTN spacesuits mainly consist of 4 subsystems. They are the body structure, the environment control and life support, the medical surveillance and remote measurement, and the control and display subsystem. China developed and constructed many ground infrastructures for the EVA training to simulate space environments such as thermal vacuum and microgravity and so on. This picture is the EVA procedure training. This picture shows the technologies carrying out low pressure training. The left picture is the Chinese natural buoyancy facility, and the right picture is a picture of the training in natural buoyancy facility. The Shenzhou 7 spacecraft is like this. It consists of the propulsion modular, the descending modular, and the orbital modular. The orbital modular of Shenzhou 7 was not only the working and living modular for technologies, it also served as the airlock for EVA. In the Shenzhou 7 mission, a small satellite was released. The satellite weighed about 40 kilograms. Its main task is to take the photo of the spaceship after being released and demonstrating flying around the orbital module after the spaceship is in entry. Utilizing the accompanying flight test, we accumulated experience in relative track, measure, and control of the two in-orbit spacecraft. And as a result, we gained experience in ground-based navigation for reservoirs. During the flight of Shenzhou 7, the TDRSS test was conducted. The test is perfect. On 27th September, on the 29th circle, astronaut Zai Zigang and Liu Bomin, wherein China developed Fei-Tian and Russia imported Orlan-M EVA spacesuits respectively, performed Chinese first EVA. As scheduled, Zai Zigang retrieved the scientific experiment devices. At 17, the astronaut safely returned inside the module and closed the hatch. It marked the EVA was successfully accomplished. In 28th September, the descent module of Shenzhou 7 spaceship landed safely and accurately in the scheduled landing site and entered Morgania. 3 astronauts came out of the module in good health. The Shenzhou 7 EVA mission achieved a complete success. Based on the existing space access technologies, China will continue to conduct the second phase of the second step and also the third step of the manned space flight program. In the future, first we'll master and make breakthrough on reentries and docking technologies of spacecraft, and then we'll launch and operate a space laboratory. And we'll also build and operate a space station and conduct manned lander mission conception study. The next objective of the second step for China's manned space engineering program is to carry out space reentries and docking and master basic technologies for long-term manned space activities. According to the plan, target spacecraft Tiangong-1 will be launched in 2011. And Shenzhou 8 will be launched for the first unmanned reentries and docking tests. Then unmanned and manned reentries and docking will be conducted after the test. After accomplishing reentries and docking tests, space laboratory and cargo spaceship will be launched around 2015. The space laboratory will provide the capabilities of technologists' mid-term stay in space. More science experiments will be carried out with the participation of technologists. By operating the space laboratory, China will accumulate experience in building, managing, and operating the future space station. Around 2020, China will launch and assemble a space station with the combination of 20-ton modulars. By that time, China will master the technology of building and the operating LEO space station. The main task of the third step is to develop of the space station's core modular, the experiment module 1 and experiment module 2. And the second will orbital assembly finish the orbital assembly of 60-ton manned space station. The manned space station operation orbit is about 400 kilometers. The inclination is 42 degrees, and the rated crew number is 3. Astronauts will stay in space for long duration and carry out large-scale space application. And the technology experiments, the lifetime of the space station is about 10 years. During the course of the third step of China Manned Space Flight Program, we will conduct manned lunar mission conception study, validate the key technologies, and finally pave the way for manned lunar exploration mission. Most recently, Chinese have selected 45 primary candidates, including 15 women from the Air Force pilots. Finally, 5 men and 2 women will be selected as the new candidates of the next generation of technologists. This is the first time for the Chinese to select and train women technologists. The purpose for China to develop a manned spaceflight program is to peacefully explore and use the outer space for the benefits of mankind. We believe through our own efforts and the international cooperation, the purpose will be realized. Thank you.
Mr. Chairman, ladies and gentlemen, good morning. It's a very pleasure to present some activities of CLEP. CLEP means China Lunar Exploration Project in the near future. In January 2004, China State Council approved first phase of China Lunar Exploration Program, Lunar Orbiting Exploration Chang'e-1 project. In China, we are 3 phases in CLEP: orbiting in 2007, landing with 1 rover in 12, and sample and return before 17. Chang'e-1 orbit was launched in October 24th, 2007, which became the third milestone of China's space industry. This is flight profile of Chang'e-1 orbiter. The major systems of Chang'e-1 include structure, thermal control, power supply, GNC, thruster, TT&C, directional antenna, and OBDH. We have different payloads. For example, CCD camera for image spectrometers and 3-dimensional images of lunar surface. Laser arithmetic for surface topology. Gamma ray and X-ray spectrometer for elements distribution, and a microwave detector for thickness of lunar nucleus, for example, helium-3, and the solar high-energy particle detector, and so on. This invention developed in China. After 1 year launched, Chang'e-1 accomplished all scientific and engineering mission goals. Then, we have done some extended missions. Lowered the orbit into 100 kilometers lunar orbit, after into 15 by 100. In first Marches this year, Chang'e impact lunar surface. These experiments of Chang'e-1 extended mission gained more engineering experience for subsequent lunar mission. Now, we have obtained about 1.37 terabyte data. All scientific analysis based on this data. This is scientific achievements of Chang'e-1. This is the first image. The scientific achievements and NASA solid dimension composition of first lunar surface image. This is the first lunar far side image. This is image North Pole and the South Pole. We have obtained a global DEM model of the moon with resolution 3 kilometers. We have obtained also the global map of 14 elements distribution. Here we show the U abundance. This is a lunar daylight brightness temperature map. Based on this brightness temperature map, we can estimate the thickness of soil. And also, we have obtained the scientific achievements of Chang'e-1 on another side. This is solar window in Earth's magnetosh. In 1st March this year, Chang'e-1 impacted Moon at the predicted location by command. The right images are taken by Chang'e-1 orbit CCD camera before impact. It's very clear. Now, I would spend the most time to present the latest update of CLAP. In the time coming soon after Chang'e-1 success, we have planned Chang'e-2 orbit, Chang'e-3 lander and rover, and the third phase of CLAP. Also propose one mission for Mars exploration based on Chang'e-1 and 2, also based on the second phase infrastructure. Chang'e-2 will be launched in October the next year with the different payloads and orbit from Chang'e-1. For example, the camera show with a very good resolution, better than 10 meters. And the orbit is 100 kilometers. This is mission orbit. The scientific objective of Chang'e-3 to investigate the landscape of lunar surface and the geological structure of Moon, to investigate material composition and usable resource of lunar surface, to study lunar internal structure and to build up an observatory based on Moon. This is the flight profile of Chang'e-3. The mission orbit is 100 kilometers. This picture shows the segment of power descent of Chang'e-3 lander. From the 15 kilometers, it begins the descent. And the final 4 meters, it's fully falling and touchdown on Moon. The engineering system of Chang'e-3 mission consists of 1 lander and 1 rover, launched by Chang'e-3B in Xichang. For Chang'e-1 in China, only antenna of 18 meters. For the second phase, we shall have 1 big antenna 64 meters and 1 35 meters. also use VLBI system. For the data acquisition, it's an antenna of 50 meters. Now, we are developing some instrument and the lander and the rover. Now we show the structure module with a system of the rover prototype and the test of landing leg and the rover prototype and the test. Now, I give all the overview of Chang'e lander and the rover. Launch date in schedule before 2013. Launch mass about 3750 kilogram. The first choice landing site is Lambo, near side. The third phase of CLAP. The probe consists of one ascending stage. Ascending stage consists of two parts, one lander and ascending stage, one return capsule and one orbit. Launch rocket shall use the China, the biggest new rocket, Chang'e 5E. The goals of this mission is robotic sample and return. Performance before 2017. For us, the key technology is sampling and return. This mission shall demonstrate necessary technology for robotic exploration and future more deep space exploration, even manned lunar exploration. Also, the scientists have proposed one mission for the Mars exploration based on Chang'e 1 and 2 technologies. Also, the second phase infrastructure. The capacity of Chang'e 1 and 2 orbit, Long March 3 Celsius launch rocket, and the Chinese deep space ground station developed in second phase of CLAP, make it possible for China to perform a Mars orbiting mission in 2013. But this is not government plan. It's only the proposition by scientists. The research has been conducted to study feasibility, and the proposal will be performed sooner or later. Before finishing my speech, I am very glad to invite you all to participate in Global Lunar Congress in Beijing next year. In this Congress, we shall discuss how to resolve the problem of lunar exploration and how to build a moon village, a true peaceful moon village. And we organize some different technique tour in the different institute and university. Of course, we shall visit the Great Wall also. Thanks for your attention. Merci à vous tous.